The spherical blowout preventer, which is positioned at the top of the BOP stack, is the first preventer you should activate in an emergency. First developed by Schaefer in 1971, it is designed to stop a blowout under almost any circumstances. A spherical blowout preventer will seal automatically around any shape or size. Kellys, drill pipe of all sizes, tool joints, drill collars, casing, wireline, even an open hole. The spherical BOP automatically adjusts its closure to fit whatever is in the hole. The sealing element in a spherical blowout preventer resembles a large sphere-shaped jaw. The teeth in the jaw are individual steel reinforcing segments that form a skeleton for the circular rubber portion of the sealing element. The preventer is activated hydraulically. When hydraulic fluid is pumped into a chamber below the piston, it forces the piston upward against the bottom of the sealing element. That pressure in turn causes the entire sealing element to move upward. Because the element is shaped like a sphere, the upward movement causes the sealing element and the steel segments to move into the well bore until they seal against the drill string, or, in the case of an open hole, against each other. N.L. Schaefer spherical blowout preventers are available with either bolted or wedge covers. The smaller BOPs and those with lower working pressures are built with bolted covers and are painted blue. Larger BOPs and those with higher working pressures are designed with wedge covers and are painted white. In bolted cover models, the upper housing fastens to the lower housing with studs and nuts. Wedge cover models fasten with locking segments and a locking ring. The sealing elements for spherical blowout preventers are made in both natural and nitrile rubber for reliable operation in any well bore situation, including both water and oil-based mud, H2S, and low temperatures. The spherical preventer has just 5 major parts: the upper housing, the sealing element, the adapter ring, the piston, and the lower housing. A 3,000 psi hydraulic accumulator system, commonly used on drilling rigs, operates the spherical BOP. The accumulator system should include hydraulic fluid opening and closing lines, a hydraulic regulator, and an accumulator bottle installed in the closing line. The hydraulic regulator is required to prevent the operating pressure from exceeding the recommended 1,500 psi closing pressure. It also can adjust the operating pressure for stripping or for closing on large diameter casing. The accumulator bottle serves to bleed off a small amount of hydraulic pressure to permit stripping operations when the BOP is closed. When the preventer is closing on an open hole, an operating pressure of 1,500 psi is sufficient to close it. Please refer to your operator's manual for recommended pressures when closing on casing. When hydraulic fluid is pumped into the closing chamber of the blowout preventer, it puts pressure on the piston, which is located below the sealing element. The hydraulic pressure causes the piston to rise and push the sealing element upward. Because the sealing element is shaped like a sphere, the upward movement also produces an inward movement, which pushes the rubber sealing element and the steel teeth around the drill string. The rubber sealing element, supported above by the steel teeth, controls wellbore pressure. When there is no pipe in the hole, the sealing element moves inward until it closes on itself to seal the open well bore. Well bore pressure even assists in maintaining the BOP seal, since it presses upward on the sealing element. Once activated, the blowout preventer remains closed until you apply hydraulic pressure to the opening hydraulic line. If stripping is required, slightly reduce the hydraulic pressure on the sealing element to allow the element to expand and contract slightly to permit tool joints to pass through it. The minimum pressure required to maintain a seal during stripping will vary, depending on the particular sealing element and its service history. The N.L. Schaefer Composite Catalog contains guidelines to determine initial closing pressures for stripping operations. Before you install a spherical blowout preventer, you should clean, inspect, and test it. Most rig hands prefer to clean, inspect, and test the blowout preventer after each well to save installation time at the new well. First, clean the preventer thoroughly. Remove the upper housing if time permits. The disassembly procedure will be described later in this program. Use steam or high-pressure water to clean the exterior and interior surfaces, the upper housing, the bore areas, and the adapter ring. Use high-pressure water to clean the sealing element. You also may use diesel fuel to clean the exterior, upper housing, locking ring, and adapter ring. However, diesel fuel should not be used to clean other parts of the BOP, since it is flammable and will damage rubber goods. After you clean the BOP, blow it dry with compressed air if it is available. Then grease the dome and piston. Use water and a wire brush to clean the studs and/or nuts, the lifting eye threads, and the jack screw threads on wedge cover models. Lubricate the threads according to the instructions in your operator's manual. Use an emery cloth to clean the ring groove and sealing areas. Lubricate the ring groove according to the instructions in your operator's manual. Use sandpaper and an emery cloth to clean the spherical surface of each housing and to clean the piston. Wipe the seals and wear band clean with a damp cloth. Next, visually inspect the bore of the upper housing and run your hand around its surface to check for nicks, pits, and abrasions. If you find indentations of more than 1/8 of an inch, call your N.L. Schaefer service representative. Next, look through the bore of the upper housing to visually check the piston and lower housing bores for excessive wear. For a dual spherical, you will need to use an extension lamp or flashlight to see the intermediate and lower housing bores and piston bores. If you find wear of more than 1/8 of an inch in the diameter of the bore, call your N.L. Schaefer service representative. Finally, inspect the sealing element for cracks, gouges, and splits. If the element is worn, conduct a wellbore pressure test to see if the element leaks. The pressure test is described later in this program. Lubricate the outer surface of the sealing element to reduce wear and to prevent scoring of the upper housing. If the BOP must be stored between wells, lubricate it, cover it with polyethylene, and elevate it on 2x4s to protect it from weather and corrosion. To install the spherical preventer on flanged and studded connections, first inspect the stud threads and stud hole and install the ring gasket. Next, hoist the BOP using the lifting lugs and lifting shackles and install it on the mating flange. Check the stud threads and stud holes again, then lubricate and install the studs and/or nuts in the alternating pattern illustrated in your operator's manual. To install the spherical BOP on hub connections, first install the ring gasket and lower the BOP as you would for flanged or studded connections. Then clean and lubricate the raised surface of the hub, the internal surfaces of the hub clamp, the stud threads, and the nut faces according to API specifications. When you assemble the clamp joint, be careful to maintain an equal distance between the two clamp halves. Tighten the studs alternately from one side to the other so the joint remains level. After you've installed the spherical BOP, install an accumulator bottle in the closing line to accommodate stripping operations. Then connect the opening and closing hydraulic lines to the opening and closing ports of the blowout preventer. Each spherical BOP is equipped with at least one port for the closing line and one port for the opening line. The opening port is always the top port, although some of the larger BOP models are built with additional hydraulic ports. Only 2 hydraulic connections, one opening, one closing, are necessary. When the hydraulic hookup is complete, test for hydraulic pressure leaks by applying closing hydraulic pressure and checking for exterior leaks. Proper BOP operation and maintenance requires more than an initial inspection and correct installation. N.L. Schaefer's preventative maintenance program outlined here can help you detect operating problems as they occur. By following this maintenance program, or the one designated by your company, you will be alerted to any problems with a blowout preventer and will have the opportunity to repair them so the preventer is always ready for emergency action. The N.L. Schaefer preventative maintenance schedule is designed with a flexibility to coincide with routine rig overhauls and normal rig moves between wells. Your responsibility in the N.L. Schaefer program is to test the function of the sealing element on stationary drill pipe at least once a week to clear it of mud and cuttings. You also should clean the blowout preventer weekly. Once a month, you should conduct a visual inspection and well bore pressure test. The same inspection and pressure test sequence should be repeated whenever the BOP is moved to a new well. You also may have other responsibilities set by your company. You should keep records of your inspections and test results. To begin the monthly visual inspection, check all nuts and studs for damaged threads. Next, visually inspect the upper and lower housing bores. Look for evidence of wear from the rotation of the drill pipe against the inner diameter of the preventer. If any nicks or gouges in the bore are more than 1/8 of an inch deep, call your NL Schaefer service representative. The second part of the maintenance check, the well bore pressure test, enables you to check the operation of the sealing element and of the well bore pressure seals. To perform the test, you may leave the blowout preventer on the BOP stack, or you may install it on a test dump or on a blind flange. Next, install a test pipe or rod in the well bore or through the center of the preventer so the pipe is supported by the test dump or blind flange. If you are testing on a test dump or blind flange, anchor the test pipe on the box and pin bolt it into the stump or flange. Anchoring is necessary to prevent simulated well pressure from forcing the test pipe upward out of the preventer. If you are testing on the stack, use a threaded well bore plug as the test pipe anchor. Do not use the sealing element to anchor the foot of the test pipe. It will damage the rubber in the element. Finally, install a gauge and valve in the closing and opening hydraulic lines. To begin the test, fill the preventer with water. Apply 1500 psi closing hydraulic pressure to close the sealing element around the test pipe. Then pump the water with a test pump until the test pump gauge indicates that the pressure inside the BOP has reached its rated working pressure. Maintain the well bore pressure for 3 minutes while you watch the pressure gauge. The gauge should indicate that the well bore has reached the appropriate working pressure. It should remain at that reading for the full 3 minutes of the test. If the well bore pressure remains constant for the full 3 minutes, the preventer has passed the pressure test and can be returned to service. If the gauge indicates a pressure drop during the first 3-minute holding period, the sealing element, a well bore pressure seal, or the ring gasket may be leaking. However, since the sealing element contains a large amount of rubber, what appears to be an indication of a leak may actually be caused by the initial movement of the rubber as it seals. To check that possibility, continue pumping in enough pressure to maintain the well bore pressure rating for 3 minutes. The 3 minutes of constant pressure will allow time for the rubber in the element to stabilize. At that point, maintain the appropriate well bore pressure for 3 minutes as you watch the well bore pressure gauge. If the pressure remains constant for the full 3 minutes, bleed the well bore pressure to 0 and apply opening hydraulic pressure to open the BOP. Then repeat the pressure test. If there is no well bore pressure drop in either holding period, the preventer has passed the pressure test and can be returned to service. If the pressure does not remain constant, continue pumping to hold the well bore pressure as you check for leaks. Look in the area around the test pipe, at the bottom connection, and in the well pressure piping system. If you find no leaks, stop pumping the well bore pressure and observe the pressure gauge for another 3 minutes. If the well pressure drops, the leak most likely is at one of the 3 well bore seals: the piston inner diameter upper seal, the adapter ring inner diameter upper seal, or the adapter ring top seal. Bleed the well bore pressure to 0, apply opening hydraulic pressure to open the BOP, then either replace the seals or call your NL Schaefer service representative to replace them. After you replace the seals, conduct another well bore pressure test. If the pressure still drops during the test, the leak may be at the sealing element. To conduct a hydraulic pressure test, first install a gauge and a valve in both the closing and opening hydraulic lines. The gauge should be installed between the valve and the blowout preventer. Close and open the sealing element 3 times to clear all air from the system. Then apply 1500 psi closing hydraulic pressure to close the sealing element. Wait 2 to 3 minutes for the rubber in the element to stabilize, Then close the valve in the closing hydraulic line and watch the pressure gauge in the line for 3 minutes. If there is no pressure drop, the seals at the piston outer diameter and inner diameter are holding, and you may go on to test the opening line. If there is a pressure drop, the leak most likely is at the piston OD or ID seals, or both seals. A leak at the piston OD seal will produce fluid or pressure in the opening hydraulic chamber. A leak at the piston ID seal will be visible in the well bore. If the pressure test indicates seal leaks, call your NL service representative to replace the seals. If gauges are not available for the hydraulic lines, check for internal leaks past the piston by disconnecting the opening hydraulic line and watching for a brief oil flow from the opening outlet. The flow should stop quickly. If it continues to flow, it is an indication of a leak at the piston ID and or OD seals. Call your NL service representative to replace the seals. To test the opening line, repeat the closing line test sequence, applying opening pressure and closing the valve on the opening hydraulic line. If there is no pressure drop, hydraulic seals 3, 4, and 5 are holding. If there is a pressure drop, one or more of the 3 seals is leaking. Call your NL service representative to replace the seals. If the hydraulic pressure test indicates that all hydraulic seals are holding, or if the seals have been replaced and tested, yet a repeat of the wellbore pressure test still indicates a leak, you should replace the sealing element. First, bleed, disconnect, and vent the hydraulic chambers. To remove the sealing element from bolted cover models, remove the stud nuts that hold the upper housing and lift off the upper housing with a hoist. Screw 2 eye bolts into the sealing element and lift it out. Wash out the interior of the BOP and blow it dry with compressed air. The adapter ring seals the piston and the hydraulic chambers from mud, cuttings, and wash water. Next, clean and lubricate the lower housing studs and nuts. Lubricate the outer surfaces of the steel segments of the new sealing element and the upper housing to reduce sealing element wear and to prevent scoring of the upper housing. Install the new sealing element on top of the piston and install the upper housing and stud nuts. To remove the sealing element from wedge cover models, remove the locking ring nuts, then screw 2 eye bolts into the locking ring and lift off with a hoist. If it is difficult to remove the locking ring, install 6 jack screws in the ring to raise it, then lift it using the eye bolts. Lift out the locking segments by hand. If they are difficult to remove, use a sledgehammer to drive them toward the center of the BOP. Screw 2 eye bolts into the upper housing, lift it out, then screw 2 eye bolts into the sealing element and lift it out. Lubricate the outer surfaces of the steel segments of the new sealing element, the upper housing, and the locking segments. Install the new sealing element on top of the piston. Lower the upper housing. Set the locking segments in place on the upper housing, pushing them out so the locking ring can be lowered into place. Install eye bolts in the locking ring, lubricate the ring, and lower it into place over the studs. And tighten the nuts onto the locking studs.